Hello, it is Sunday, July 15th. This is geometry. And I want to point out we are covering the first section, 1.1, identifying points, lines, and planes. So here are my learning targets. I can name them. I can also name segments, rays, and opposite rays, and I can also sketch intersections of lines and planes. First of all, let's start with our warm-up. Graph the inequality, x is less than or equal to 3. This is just one-dimensional inequality. I'm going to place a 0 and a 3. You don't have to put all those little lines in there. Keep in mind there's going to be a solid circle. It's because it's less than equal to. Notice the variable is to the left, so we'll shade to the left. Remember what this means is all x's less than or equal to 3. In a set notation, it would look like this. Negative infinity to 3 with a square box. You put a square box if it's actually filled in, if you touch that point. You put a round parenthesis if it goes on forever. All right, part B. This is an AND type equation. Remember when we were solving those in Algebra 1? We're going to place negative 2 and 3. Put that 0 in between. They're both going to be solid circles, and equations are shaded in between. How about C? Caitlin has more than 5 but fewer than 11 fish in her aquarium. So she is in between, and remember, and equations shade in between. She's in between 5 and 11, so we have 5 less than K is less than 11. Now notice it doesn't say, it says fewer than, it doesn't say equal to also, it just says fewer than 11. So when we graph this, it's going to go between 5 and 11. These are open circles, shaded in between. So far so good? Alright, let's start off with some definitions. Now I hate to say it, but there are going to be some definitions, postulates, axioms, theorems, all those things in geometry, and they have to be defined. We will be talking about Quizlet later on, and I will show you some Quizlet pages that have already been done that are actually done well, so you won't have to reinvent the wheel. Well, in any case, here we go. Definitions. A point has no dimension. It's represented by a dot. We can call this point A. A line is one dimension. It's represented by a line with 2 arrowheads, but extends without end, meaning goes on forever. Okay? If you don't put those arrowheads on there, it's called a segment. So you want the arrowheads so we know it's a line. You have to be precise. And this is the one little part that I want to really point out right here. Through any 2 points, there's exactly one line. You can use any 2 points on the line to name it. Okay, so that's really important. A plane has 2 dimensions. It is represented by a shape that looks like a floor or a wall, but extends without end. So it goes on forever. And again, here, let's use my little clicky pen. I'm going to put a little star here. Through any 3 points not on the same line, okay, so they're not collinear. We'll hit that in a little bit. There's exactly one plane. You can use any 3 points not on the same line to name a plane. So to follow up, here's a picture of 3 points. Here are 2 different lines. This is line AB or line BA. This is line L. Plane P. So remember, they go on without bounds. All right, collinear. Collinear are 3 points that are points that lie in the same line. It can be 3 or more. Usually you don't say 2 because that makes a line. Coplanar are points that lie in the same plane, so 3 or more. Non-collinear. Probably should put that in there. Non-collinear points. And you are also going to notice that in geometry we abbreviate a ton. All right, here we go. Example 1. So in this shaded picture, I have a bunch of points inside. There's 2 intersecting lines on this plane. This is plane J. We have a point G here. This plane is intersected by a line FK or KF right at that point. So sometimes you'll see a dotted line go through there. And point E is outside the plane, so it's point F. All right, name 2 other names for line CD. Well, line CD also could be line I. or it could be DC, and you have to put a line with arrowheads right above DC. Also, usually points are capital letters. Give two other names for plane J. All right, so plane J could be points, we'll call it plane ACD. Notice I'm not going to pick ACB because that would be in a straight line. Or you can say plane DBG. Okay, so there's a whole variety of things you can use. Don't use E or F because they're not on plane J. Name 3 points that are collinear. ACB. And name 4 points that are coplanar. So you just want 4 points that are on the same plane, not in a straight line. So I'm just going to pick, how about ACDG? That works. So you just don't want to pick E and F. All right, next page. Hopefully you can see this. Hopefully this is recording. I haven't done this in a long time. All right, some of the things we're going to point out here. Again, more definitions. Some of these you've already seen. A point, a geometric element that has 0 dimensions. So it could be called P or point P. Usually you just say P. Lots of times I'll just point P. I would do that. A line is a collection of points along a straight line with no ends. So it goes on forever. You can call this AB or BA. Notice it's kind of hard to see. There are little arrows in the end. I'm going to make them larger. Line segment. A line segment is every part of a line that contains every point in the line between its endpoints. So basically all the stuff in between here. But it does have an end, X and Y. As soon as you apply a measurement to this, you'll remove that line. So if I say XY is a length of 5, you'll write the measure of XY is equal to 5. You'll remove that line. Array is an endpoint with a array is a line with a single endpoint that goes on and in one direction. So here's our endpoint, and it goes on forever. This is ray. I'm going to put the arrow after the G, PG, but it's not, sorry, that's a Q, PQ, but it's not QP. You cannot flip those around like you can a line. And a plane goes on forever. Lines are not in the same straight line. All right, opposite rays. Okay, this is an example of opposite rays. You have ray AX and ray AY. Notice they are in a straight line. These are 2 different rays, but they're not opposite. So it's not a straight line. This makes a angle less than 180. Okay. DE and ED are not opposite rays. Okay. You have to have the same endpoint for opposite rays. All right. So how about this? Example 2. Name another. Give another name for segment PM. Segment MP. You can't say PL because PM will have a certain length and PL is a little bit shorter. It won't include the points in this part. Name all the rays with endpoint L. LP, LN, LM, and LQ. Wish I would have left a little more space for that. All right, so far so good. This is where the fun begins. You'll be able to tell if you have any artistic talents at all. So here we go. Key concept. Here are 2 planes that are intersecting, and when they intersect, it's going to intersect with this line, AB. Here's a line intersecting a plane, and it's going to intersect at this point. We can call it point A if you want. And here are just 2 lines intersecting. We'll just call it an intersection at M. So intersection is where things cross. All right. Now, what you need to do, and I know it's one of the benchmarks, is you have to be able to draw these, kind of sketch them. So, sketch a plane and 2 intersecting lines that intersect the plane at separate points. So, I'm going to draw a plane. It's usually best to try to draw a big plane And the lines have to intersect, but they're going to hit the plane at two different spots. So it's like going behind it. What do you think? The lines intersect right here, they intersect the plane right there. Here's an example of it visually. Can you see that? I kind of made this little model a second ago. Pretty cool, huh? Okay, now how about sketch a plane and two intersecting lines that do not intersect the plane. Okay, so I'm going to sketch a plane. Remember, planes go on forever, but then my lines are going to intersect, but they're going to be above it. So what I would do here is have, let's see here, can you see that? Have these two intersecting lines like parallel, like above it. Sketch a plane and two intersecting lines that lie in the plane. Okay, so I'm going to make a big plane here. And the lines are in the plane. So basically, if I say that the lines are just in the plane on top, just within. So it has just one dimension. Sorry, 2 dimensions. The next one. Sketch 2 intersecting planes, and they intersect in a line. Okay, so this is kind of like that picture that's up here. Good luck with that. This always drives me crazy. I'm not really good at this one. I'm going to try. So I have a plane, and for some reason, they usually make parallelograms. I'm not sure why. And let's get a vertical one. Let's see. Oh, that doesn't look too bad. And they intersect, here, I'll do this in red. They intersect right here at this line. And then, of course, this one, sketch 2 planes. Oh, actually, let me show you what this could look like with a 3D model. Easiest way to do that is take 2 pieces of paper, slice it. There you go. They intersect at this line right there, where the pink and yellow meet. And last but not least, just make 2 parallel planes, one above another. Okay, so basically if I took these 2 planes, I'd have one above the other, so they're like parallel. Okay. I know it seems easy, but it's just, so far, it's only the first section. We will be using all of this stuff throughout the whole year. Okay, so here we go. Let's do a little review. Can you name 2 planes? One of them is plane R. And we can say that would be this one is flat. And then we do plane ABF. Name 4 points. How about A, F, B, and C. Name 2 lines. Line M. And we can do line AB. Of course, there are others. Name a pair of opposite rays. BF with the ray above it. BC with the ray above it. How about a line segment? CB. Only put a segment, don't put arrows at the end. A line that intersects both planes. That would be FC or CF. And 3 collinear points. F, B, C. Should label points. Okay. Again, a little bit of a review. And there's your assignment. Everyone, have a nice weekend.